Welcome back to our final online session. We are delighted to have you with us. For those of you who've been with us for all 12 sessions, a special thank you to you. And for those of you who are watching this in the archives in the future as recording, we also thank you for engaging with our online community, even at this future date that you're watching this. But today we're here live with three special guests. I'm going to have Len Hirsch introduce them and have him introduce himself in just a moment as well. He has a really interesting perspective on climate change and the Smithsonian Institution's role in researching and working on this issue, and you're going to learn about that as well. So this session, though, is no different than the others in that we do want it to be a dialogue, and we do want you to share your questions and comments with us. So don't forget, you can use the button over on the left side of the screen, the area on the left side of the screen, to submit your questions at any point, and we'll try to integrate those into the course of our conversation. So with that, I'm going to go ahead and turn the floor over to Len Hirsch.
Thank you very much. Welcome, everyone. I'm the top person with the bow tie and wearing it in the photo and wearing it here, and I want to introduce my colleagues here. Scott Richardson, the second person, and Ed Geary, the third picture you see. We're going to talk in different order there. Scott is with the Corporation for National and Community Service, and he'll talk a little bit about their opportunities and how they engage in outreach and work on climate change, and Ed with the GLOBE program, Global Learning and Observations to Benefit the Environment. But before we engage in our discussion, I want to use this last session to try to tie together many of the strands that you've heard in the last 11 sessions on climate change, science, and education here at the Smithsonian. But the Smithsonian isn't insular. You know, we're not this island doing work. We work with people around the country, around the world on these issues. So our scientists, our educators, our bureaucrats, which is what I am, work and collaborate every day with other people. So I want to try to put that together, and having my colleagues from GLOBE and the Corporation for National and Community Service gives an example of ways that we work together and reach out with our counterpart organizations. The Smithsonian, you never got what is the Smithsonian, and it's a long story, but we were founded over 158 years ago in Washington for the increase in diffusion of knowledge. That is just a wonderful mission to have. How better can we exemplify the American experience than to increase and diffuse knowledge? Increase means the research and the analysis that you've been hearing about, from biology through culture, innovation, art. It is truly extraordinary. Diffusion means education. How do we get the information that we have learned, that we learn with our colleagues, out to people, the public, to government, to policymakers? How do we do it? And you know, through the museums, which are very well known of the Smithsonian, or many of you know, but the museums are only half of the institution. We do publications. We do formal curriculum, developing for schools. We do informal education, such as this, such as at all of the museums. There's a full range of diffusion techniques that we use for information. All of that is based on research. All of that is based on collaborative science, as you've been hearing about. We work with the government. We work with private sectors. One of the things that makes the Smithsonian quite special, and you've been hearing about that if you've been participating, is that we really focus on long-term understanding. Many research projects, partially because of how funding is done, have to focus on doing something quickly or in the short term. When you're trying to understand climate change, you need a long perspective. You've heard that from Scott Wing in paleontology, where we look back millions of years. How do we do that? How do we measure that? We base a lot of this work on our collections, whether they be fossils or plants or coral reefs. We look at specific sites at long term. So we may have 75 years of data on a specific site, as we do in Panama, which enables us to understand the natural changes and which ones are human-induced. We do Earth observations from satellites, from the Air and Space Museum and the Smithsonian Astrophysics Observatory, and we do very detailed land-based observations with people looking and observing, whether it be how ants move, how insects pollinate plants, or very much over time how the ecosystems are responding to change. We obviously are looking at how humans deal with change, how they bring it, and one of the things that the three of us, I hope, will focus on is how humans learn and therefore can change what they're doing before disaster strikes. You've heard a little bit, and I just want to reiterate that the Smithsonian has actually been doing what we would now look at as climate change research almost since its inception. Our first secretary was very interested in technology, but he was also interested in understanding weather patterns. And his work was fundamental to our truly understanding how weather moved in this country. Before the Smithsonian started its research, we actually thought that weather went from east to west. Basically, we did. Why shouldn't the weather? Well, it was only when he was able to develop a data stream where we truly understood weather patterns over time across the continent that we were able to start understanding that it tended to go from west to east, and some of the patterns that we now know so much about and that we hear every day in our weather reports. But that was very new in the 1860s. So from the beginning, we've looked at instrumentation. How do you measure and how do you collect the data? So in Secretary Henry's day, the first secretary, the telegraph was used to collect data across the country in that weather study. We have people who are now, literally as we speak, developing new instrumentation that's going to be put on glaciers in the Arctic to truly understand on a day-to-day, month-by-month, year-to-year change of what's going on in terms of those glaciers. New instrumentation never seen before. Again, as I said, we work over time, but we have these wonderful collections. So we repurpose them. As you heard, we can use our art collections to understand ecology or representations of ecology from 100 years ago. We're taking biological collections that were collected 80 years ago and studying them chemically to see how different they are today from what they were 60, 70 years ago. Because we know we accumulate different sorts of chemicals. Really quite exciting reuse of the historic collections. We work around the world. While the Smithsonian only has a physical presence in a few countries, our scientists in a yearly basis work in about 160 different countries. So we're very happy to collaborate around the world. Fundamental to our work is that we're trying to understand the baselines. Nancy Knowlton talked about, if you heard her earlier today, the concept of shifting baselines, where what we think is natural is what we grew up with. Well, from a scientific perspective, what we're trying to find out is what is the natural baseline. What happened before things started changing, or what is the natural patterns of changes? And that is very important to all of the work that we do. All of this work that you've heard about from different fields comes together, not necessarily at the Smithsonian, by other people who start using it to develop climate change models and synthetic approaches to it. The Smithsonian also does, in addition to the research, enormous amounts of outreach. At the formal level, The International Panel on Climate Change has been hosted already once by the Smithsonian and will be hosted again this year in Panama, where our scientists are very active, and we play a forum and a convening role for this and other meetings. We've had a number of series of exhibitions at the National Museum of Natural History, that's NMNH. Come from Washington, we always put in acronyms, but the National Museum of Natural History for the last 14 years has been having a series called Forces of Change, and they've been looking at different parts of global change, climate change through that. We're hoping that we'll have another major exhibit on climate change coming up in the next few years. We also work on what's known as interagency discussions. This is where people from different parts of the government get together to actually coordinate across. You may not think that there's much coordination within governments, and there's always the ability to do more, but there's actually quite a bit. And we are engaged from the Smithsonian, bringing our research to the table, bringing our advice to the table. The UNFCCC is the UN Framework Convention on Climate Change. Very important meetings, in the news a lot. Well, there's a lot of preparation that goes into those meetings, and we go to many of the preparatory meetings and help bring our science into it. We also do, as I mentioned, lots of publications, and we have another education office. Where the good news is that we have different ones, and this one, the NSRC, the Natural Science Resource Center, is a collaborative program with the National Academies of Science to develop core curriculum in science. And while the curricula are not on climate change, many of the elements of that curriculum, and I'm giving you the website here, do feed into the streams of climate change research, whether it be paleontology, chemistry, or biology. So we explore the evidence, we try to understand the baselines, and we are looking at human impacts. We use these to develop scenarios, what if. So you've heard from a number of the people, the scenarios out of the International Panel on Climate Change and some other places of trying to predict what is the range of carbon in the atmosphere, other greenhouse gases, what will be the impacts. And that becomes very important for us as citizens of the world to be able to start saying, do we want that? If not, what should we do to change that? All of these discussions, whether they be on the social side or the science side, is actually driving really substantial work here at the Smithsonian and with our colleagues in the development of new technologies. New technologies to collect data, new technologies to interpret data, and as you were hearing before in the last session, I hope, new innovations and technologies to help us live better. So it is really an important element of what we do is to develop both the science technologies and to support the different technologies that support all of us as humans. So we put this together, we try to figure out what we can do, and this is part of the whole climate change discussion, the ecology discussion, is part of a larger global discussion on how do we move to what is called sustainable development. Development where we do not create conditions that make future generations pay, future generations have a worse situation than we have today. And it's a shift. We've been very used to thinking that the world was infinite and that we could just take, we could pollute. When I grew up, I'm also, as Nancy, that old. The solution to pollution was dilution. That was the saying. If you got it out there, it would dilute out. We couldn't produce enough to create a problem. Well, we found out that's not true. We now have to clean up the past mistakes. The solution to pollution is not to do it. And we certainly have found that out. We have to develop new technologies to do it, but we can. That is the extraordinary thing about humans, is that when we're faced with problems like this, little steps, big technologies, small technologies will help us make those predictions wrong. So we bring this together, we try to increase the science, do more, better, greater science, finer details, better models. We work with policymakers to bring the science forward. And what we're finding, and we of course do the education, but now there's a new sense, and the internet, as this conference is doing, has really started enabling us to see how we can develop citizen science and citizen engagement in ways that was never done before, which truly is exciting, and my colleagues will be talking a lot, much more about that. We're doing some of it at the Smithsonian. We rely on counterparts to do some of that. So there's a lot to be done, and there's a lot we're doing, and there's a lot we all need to do together. So here are issues, what can you do? And before we do that, I want to ask a question from all of you, which I believe is coming onto the screen now to answer, which is, are you involved in citizen science or advocacy programs where you are now? Are you collecting data? Are you bringing it to class? Are you bringing it to other groups? And we'll hopefully get some questions on how you're doing this, but we're trying to get a sense of how engaged everyone is. And looking at this is really quite wonderful, showing the engagement.
That's great.
Of the folks here. What you need to do is bring all of your friends and colleagues along with you so that we keep those numbers up over time.
Interesting. We have some folks sharing some of the things they're doing, including one person among our audience who is pushing for his school to purchase sensors for collecting relevant data on a daily basis. And certainly if others who are among the 79 or 64% would like to elaborate on some of their own work and projects, we'd love to hear what they are in the chat box on the left.
Thank you very much, Jonathan. Absolutely. You know, high tech is wonderful. There's a lot we can do absent high tech. And I actually want to turn now to my colleague Ed Geary to talk about some of the things that they're doing with Globe on engaging people in collecting data. So, Ed?
Thanks, Lynn. First, I want to thank the Smithsonian and all the colleagues who have participated in this online conference. It's been very inspiring for those of us who have been dropping in and then going off and doing other work to see not only the science that's going on, but some of the innovation and solutions and ideas that are coming up from you in the community. One of the things I just noticed on the online poll here, too, is that many of you are already involved in science or advocacy issues. And I think I want to reiterate Lynn's comment that having this engaged group is wonderful, but I just came from a climate meeting with NASA and NOAA and other agencies here in the United States, and we were talking about how to reach out to those groups that aren't necessarily aware of or involved in the climate issue right now. And it's important that we think about different strategies to do that. As director of the Globe program, I have the great fortune of working with teachers and students and scientists in over 100 countries around the world. We engage students in working with each other and with scientists through a set of common scientific measurement protocols. It speaks to what Lynn was just talking about. How can I get instruments in my school? What things should I measure? Our program has worked with scientists and educators to develop over 55 different measurement protocols that students can go out and do, ranging from simple observations that kindergartners and first graders can do, observing clouds in the sky and measuring rainfall and a rain gauge, to more advanced measurements where students are looking at aerosol optical thickness, or they're doing pH measurements on water. And the great power of this is that when students use these measurement protocols, it doesn't matter where in the world they are, they can share data that's been collected in a similar way and verified by the scientists who are working with us in this program. We value the educational component of learning about science and the fundamental components of science as a way that leads to discovery and innovation and questions around issues like climate and water and weather and things that affect your daily life. So what we're trying to do is promote this long-term educational mission that allows students to discover with each other and with scientists the world around them, and to look at indicators of climate change in their own communities, to look at and see if they can help contribute to solutions to these types of problems in their communities. And one of the questions that I'd like to pose to many of you is similar to some of the questions of, are you already involved? What are you already doing? I've heard individuals who are doing different things, ranging from riding your bike to using recycled bags in the grocery store to reducing your electricity use. One of the questions I have is, imagine what you could do if it was collaborative, if you were working not just as one student in your classroom, but with all the students in the classroom and all their parents and all the students in your school and all the teachers and eventually your whole community, to create school and community action plans for how to address issues like carbon, CO2 production, and energy use in your community. If you get involved in programs like GLOBE, the great advantage is you not only get to share your great ideas and discover things yourself, you also get to learn what other people in other countries are doing. And in the process, one of the great advantages of you become a global citizen. You learn about other cultures and you learn about similar places to you and very different places to you. And so this is something that is very important if we're going to address this problem in the decades ahead. GLOBE takes the long view of environmental change. We know that there's an urgency related to the climate issue and to climate education, but one of our goals is to help inspire the next generation of scientists and inventors out there so that as we study these problems and learn more, we'll have ever more students interested in solving the problems at local, regional, and global levels. I also want to point out that there are many fun, engaging activities that students can do and that citizens and adults can do to discover for themselves these types of climate awareness and climate understanding initiatives. So not only in my program, the GLOBE program, where if you want, you can type into the internet now, globeprogram.org, and you will go to our home site, and if you go to our news section, you'll find out that we have students and teachers who are climbing Mount Kilimanjaro as we speak, who are looking at the different biome changes that are occurring related to climate change. They're studying everything from plants to Anopheles mosquitoes, which carry malaria and have significant health issues for people in Africa. So those are some of the programs we're doing, but there are other programs like Project Budburst that's sponsored by the National Phenological Network that's having people look at some of the things you've heard at already. When are trees blooming or flowers blooming in your region? Is it the same as it used to be 100 years ago? How can you find out? Those types of projects help engage you in looking at your local environment and then comparing what's going on in your environment to other places around the world. Again, to understand issues like climate, it's really difficult if all you have is a picture of your own environment but no other environments, of only today and not the historic record. And as we've seen, and very true and near to my heart as a geologist, 55 million years old types of studies about what climate used to look like are something that I can identify with. But I know when I first studied geology, something older than 1 million years was a very, very long time. And now something under 1 million years is a very, very short time for me. So I encourage you to get out and look at these types of programs. There are other groups like the Audubon Society. I'd be interested in how many of you already look at birds or look at other types of animals or fauna in your community, because birds are one of those indicators of climate change, as we've seen, whether it's ruby-throated hummingbirds or whether it's migration of wood ducks that we heard about earlier in sessions before. There are different indicators in your community. Journey North and Signals of Spring are two other projects that engage students and can engage citizens of all types. So if you're already actively engaged in science or in advocacy issues, but you're looking for ways to engage other people who are not yet active or interested yet in this area, a great way to raise interest and awareness is to point them to a project that is both fun, where they learn from it, and then they can look at what they can do to maybe take action or participate in the long term on that. I also have to highlight one of our sister projects. My program is located in Boulder, Colorado, one of the most beautiful places on earth, unbiasedly said. And we have a sister program up at Colorado State University called COCO-RAS, the Community Collaborative Rain and Hail Study, which was started about 7 years ago and involves adults and students and grandparents in the community taking weather measurements, precipitation. They measure hail by using styrofoam pads with aluminum foil to produce the size and distribution of hail when it's hailing, and they also take snow measurements. This allows weather forecasters to quickly track storms in a very small geographic area and help predict where those storms are going and to help mitigate both flooding damage and to help people with emergency planning. So the message here is there's lots of great, interesting, and fun projects out there. So get involved yourself if you aren't already. Engage your neighbors if they're not already involved. And I encourage you to create these climate action plans in your community that help to reduce carbon dioxide in the atmosphere, help reduce energy usage, and help you save money in the process. So I'd like to leave it at that and then turn this back to Lynn.
Thank you very much. Thank you very much, Ed. And that was great. And the work that you folks do at Globe is great. And thank you for that end. There was a question the other day to one of my colleagues about whether it's useful to replace appliances. And he punted that question to me for today. So this is a good time to mention it. It is, of course, situational based on both economics and what you have. But generally, for major appliances that use electricity, even though I believe in holding on as long as you can to almost anything, refrigerators and dryers are the two that you really need to look at. We have gotten so much better in building them, in making them secure, that it is frequently, if you go for a good, well-insulated front-load dryer or a good refrigerator, you will actually save money within a year and a half, so much on the electricity bill that it'll pay for the appliance. You have to look at your electricity usage. You have to look at the things. For all refrigerators, it's a horrible thing to do, but you should take it on to clean the back of it, where they have the filters. That is very important for efficiency, but the newer ones in those two appliances is very important. All of you should be looking at your windows and making sure that you are not losing your heat or your cooling during the summers. There are a lot of individual things that one can do to do an energy audit of your house and to save yourself money, but also, very importantly, become a lower user of carbon. And I want to use that also to segue to the work that my other colleague who's here is doing, and his organization, the Corporation for National and Community Service, is doing to really try to engage people in action on their own. So let me turn to Scott and let him tell us about Learn and Serve and the work that you're doing.
Well, thank you, Lynn. I'm delighted to be here with you folks, and am grateful for the invitation to talk about Learn and Serve and how it fits into the whole climate change puzzle. We are a federal agency at the corporation, and we have 3 large programs in our agency: AmeriCorps and its cousins VISTA and the National Civilian Conservation Corps. They engage people in full-time service to communities around the country and have an education award benefit that a member can get after doing that service. We have the National Senior Corps programs that engage older folks in all types of volunteer activities. Sometimes they mentor students, and other times they help other seniors live independently and not have to go into institutions. And then we have the program where I work, which is Learn and Serve America. And we engage young people in service learning through community organizations, through higher education institutions, and through their schools. And we look at service learning as an opportunity for students to use the knowledge and skills that they get in the classroom to address community problems that they care about. So it's a process that can fit a kindergarten class, a middle school class, or a university class. It's the same set of steps, and it begins with taking young people out and investigating the community, having them come up with their observations of the assets that they see around them and the needs and challenges and problems that they see as well. And once they take stock of some of those problems and discuss among themselves which ones matter to them, which ones have an effect on their lives, which ones they care about, many of the students revolve around environmental topics. And so the next step they go into is planning a project. All right, they've selected an environmental need. They need to do some research about that before they just jump in and try to solve it. They need to get the kind of understanding that this 3-day conference has had on a climate change, the equivalent, let's say they're going to work on watershed issues. They need to understand the geography of the watershed that they're in and what's impairing or threatening the streams in that watershed and the way the human behavior can affect water quality, just as an example. So they need to do that research and then decide, of all these threats and impairments to whatever the issue is, what project can we do to address that? And that's where the projects begin to really look different. A group of engineering students at the university level are going to do something that'll be different and more involved than elementary and middle school kids, but they're doing the same process. And third, they get out there in the community, they work with the community, and they take action on the plan. Perhaps they've found a watershed association to work with, and they've decided that there's farming practices upstream that are the root of the dead zones that they see downstream. And so they would begin to say, well, what kind of actions can we take to have an influence on the behavior of the farmers or everyone's everyday habits around the house and how it affects water quality, and what can we do about that? Or it's that there's no vegetation left along the sides of the stream, so how can we have an effect on that? So whatever it is, they jump in and they do it. As they go throughout the entire process, they're reflecting. They're trying to make sense of the experiences that they have. They're seeing the relationship between the curriculum and real life. And they're talking about this with each other, with community folks, with their teacher or professor. And then finally, they take everything they've done, reflected, learned, and they open it up and show it to the public. They show it to their peers. They show it to their school board. They show it to the board of supervisors in the community. They do it in a live event. They do it in a web event, such as we're on right now. They create a video and send it up and have it go viral and have all their friends and relatives watch it. But they show what they've learned, and that's an additional service to the community because it educates folks about the issues they've been working on. And what we do at Learn and Serve is make grants, and we have a good handful of K-12 grants. In our board of directors and our leadership and Congress have been looking at us and saying, we want you to demonstrate service learning as an effective way to get at STEM, science, tech, engineering, and math education, K-12 and higher ed. And so we've had some grant competitions that focus on that. One of the folks who got that was the American Forest Foundation. And they are funding middle schools across the country to engage students there through science, math, and other classes in energy audits of school buildings themselves, municipal buildings, nonprofit associations in their communities. And the project activity, once the students teach folks where the energy waste is coming from, is that they come up and collaborate with the owners of those buildings to come up with ways to reduce the waste of energy. And a fairly well-known higher education initiative is EPICS, Engineering Projects in Community Service, which we funded Purdue University both to do at the higher ed level and then to work with high school students on. And a couple of carbon-related projects that they've done through EPICS include the Electric Vehicle Event Infrastructure Initiative, and they've worked with Habitat for Humanity to make sure that the latest and greatest in efficiency go into the homes that are built for Habitat. Now, all of our granting by Congress has to be in domestic United States programming. We call ourselves sort of the domestic Peace Corps a lot of times, especially with the AmeriCorps members. And so there are U.S. government programs that are involved in international efforts. Ours is not one of them. The law restricts us to working domestically in the U.S.
Though if I can just add in for all of our international visitors here listening to us, their website has a lot of information, and I do encourage that you look at it and see how you can locally replicate the sort of work that they're doing. So,
and
great.
We've had delegations of visitors from just yesterday, India, often Australia, other parts of the globe come in to Learn and Serve, and they're trying to build a service learning infrastructure, much like we've done here. And of course, they're very interested in a lot of environmental issues as the needs they want to help students address. And finally, Congress directs us to fund a clearinghouse of information. It's at servicelearning.org, and it has everything you'd ever want to know about service learning, from research to syllabi to curriculum examples for all age levels to how to tie it to state standards of learning. Anything that you can think of as a question about service learning, you can go to servicelearning.org and find information there about it, and it's open and free to anybody all over the planet.
Great. Thank you very much. For those of you watching from the United States, you see we're playing on a well-known phrase here, which was only you can prevent forest fires. Well, only you can prevent climate change also, or all of us can do it. When we look at the large picture, human-induced climate change, the thing that we're going through right now, which my colleague showed, is happening at a level hundreds of times faster than ever occurred in the history of this planet. And one of the things I want to point out is when it did happen in the past, it was before there were humans on the planet. So what we heard from Scott Wing when he talked about our knowledge of change at a time when there was relatively rapid climate change is that whole ecosystems changed. Well, now with humans here, we're tied to our ecosystems. We can't afford that type of change and really keep the type of peace that we want on this globe. So we have to work with it both to bring it down and to be able to adapt. So we have a great question that has been put up on the screen for me that asks a fundamental question, which is about food security. That climate change is hampering food security worldwide, and how do we develop better resiliency? What type of technologies might be needed? Well, we at the Smithsonian do a little bit on that, surprisingly. We work with colleagues around the world. So it's a range. Let me tell you about a relatively new technology that is a global process that we headquarter here at the Smithsonian called the Consortium on the Barcode of Life, CBOL. Well, what's the Barcode of Life? If you look at products that you buy in supermarkets or stores, you'll see on many of them that there is this bunch of series of black bars with a number underneath it. And some very smart people a number of years ago realized that if you look globally at all products that are developed, that all you need is 15 numbers, a string of 15 numbers, and you can separate out every item in the world that's produced or expected to be produced for a long period of time. This enables us to computerize inventory and a number of things, transport, movement, by using the barcode. Well, some biologists started thinking, if you can do that sort of to help us with commerce, could we do this in biology? How many genes, or in a genetic sequence of the four components, are necessary to probably be able to separate all species? And what they came up with is that you probably need a string of about 400. Well, which string? So they started a large research project, which happily, I'm happy to say the Smithsonian has been a big part of, with collaborators in Canada and Brazil and South Africa and Nigeria, to try to identify which part of the genome separates us and separates other organisms in a way. And we have found that there is a component of a mitochondrial DNA that works for animals, almost all animals. There are some that it doesn't. Slowly evolving, so there may only be one of these 340 pairs that's different, but that's enough to separate a particular bird from another. Or, in case of agriculture, a particular pest from another. So it becomes very important in our attempt to develop new technologies to deal with plant pests to actually be able to find this way of, at any part in their life cycle, whether they be a larva or a fully fledged insect, to be able to identify it quickly and deal with it so that it does not harm our crops or the movement of materials. We have other projects that may be working, Solanaceae, which is a big group of plants, but it includes tomatoes, eggplant, potatoes, to make sure that we understand the genetics and the diversity of those plants so that we help communities, if there is a problem, to be able to bring in the right germplasm to be able to build for agriculture. So there is a lot of work that's going on. There's a lot more that needs to be done for food security. We need to really understand the impacts of the change that's going on. My colleague Doug Herman the other day was talking about traditional knowledge and the wisdom that has been distilled in thousands of years of traditional peoples living on the land and knowing how to be stewards of the land. Historically, some traditional peoples were very good, some actually weren't, and we have many societies over time that have actually gone extinct because they have not been able to steward their land as well. Traditional knowledge is very important, and we're working here at many parts of the institution to help preserve it, to protect it, to help communities enable themselves to see where it's coming in, where is it a way of knowing. But when you have a shifting ecology around you, we do need to develop new technologies and new science to be able to deal with the changes that are going on. So we want and we need to create some new technologies, but we don't want to then have to clean them up 10 years from now. So one of the things all of us need to do is really think through the consequences of new technologies and make certain that by cleaning up one, we're not creating another problem. Getting back, as I think we all have said, there are many things you can do as individuals, as communities, both to understand, but also to reduce your carbon footprint. That's the goal that we're all working to. And anytime you see something that's garbage or waste, the beauty of ingenuity of people is to say, how can I use that? CO2 we're now throwing into the atmosphere as waste. How can we not put it into the atmosphere, but actually use it as a product? So one of the things that I think, if I'm going to predict, which is part of my job, technologies that are going to come is that we'll actually use biodiversity. We'll use algae. Algae are wonderful absorbers of CO2. Why don't we start testing, taking smokestacks instead of going up, coming down into major vats of algae and let the algae sequester the carbon, bring it in. And then we could dry the algae. We can use it for fertilizer. We can actually use it for fuels. Where do you think oil came from? It came from lots of algae over millions of years. So that's a technology that people are working on. The Smithsonian part is to be able to identify different algae. But others will be developing technologies like that. We have to think, we have to be creative, and we have to make sure that we produce much less waste. So I believe there are some other questions that may come up, and we want an open discussion. But we want to thank you all. Hopefully what we're doing and you're doing is helping to make the predictions, the dire predictions you've heard, wrong. We can do that. We need to do that. And together we will, I hope, do it. So let's study. Let's learn as much as we can. And let's act. And let's dialogue.
Thank you very much to all three of our panelists. One quick question that came in is, does the Smithsonian Institution have a continued partnership with Globe and NSLC to work towards these future goals?
This is Ed Geary again from the Globe program. I'd say we have a consortium of other groups, not just the three groups mentioned in this, but many other groups are working on this issue. One of the great things about the climate issue is it has galvanized many scientific education service groups and business groups to begin acting collaboratively. So in some cases we have formal agreements, and in some cases we have more informal agreements, but what you're seeing is many more opportunities for groups like ours to interact and to do so on a long-term basis. So I'd say while the answer is variable to that question, the intent is yes, we do intend to continue working together to try and help address and solve different parts of this problem.
We've had people from the White House in our agency with a strong mandate to collaborate with other agencies in the federal government, but not to stop there. They're insisting that we work with the individuals at the implementation level in our program, so schools and community organizations and watershed associations, and plug them into what other departments are doing, plug them into the U.S. Forest Service and the national parks. And so trying to drive collaboration at the federal level, but making sure that the outcome of that is stronger collaborations locally so that the action is better coordinated.
Well, allow me to thank you, Len Hirsch, for bringing together our great panel and for a nice capstone to the event on global climate change. Thank you very much.
Jonathan, I want to say to everyone out there who hopefully has been listening a lot, you've been hearing Jonathan's voice and his helping to direct this. Watching him here in the studio is really quite an extraordinary feat. He's on multiple computers, managing it, reading your comments, trying to keep us on track. And you don't see a picture of him, but you should, and you should give him great applause around the world for this. Thank you, Jonathan.
Much appreciated. It's been fantastic. I would like to turn the floor over to one person who has some final words and deserves to have some final words on this conference. It's she and her team that brought this all together. Stephanie Norby, the Director of Education at the Director of Smithsonian Education. Over to you, Stephanie.
Thank you, Jonathan. I'd just like to mention that we've had people from as many as 80 different countries. We've had 3,600 people from 61 different countries who have been participating with us in this conversation for the last 3 days. I hope that we'll continue to stay in touch, and that after this concluding session today, you'll go back to the discussion boards and continue to post questions and comments. And in addition, I'd like you to post suggestions. What are topics or problems that you would like to be the focus of future Smithsonian Education Online conferences? I have the privilege of working here at the Smithsonian, and you've had the opportunity in the last 3 days to just meet a few of the colleagues that I'm able to work with, so that every day I have a chance to learn and grow myself. But now, through this community that we've built online, I've had even a larger opportunity to talk to people in Argentina or Pakistan, all over the world. So let's stay in touch and continue to post your comments and questions and write to each other and to us so that we can continue to build this community about this important topic. And before I conclude, I also want to mention my colleague, Stevie Engelke, who is the Director of Programs in the office, who worked very closely with Learning Times with Jonathan Finkelstein and John Walber at Learning Times to produce this event today. So thank you for joining us, and we look forward to talking to you again soon.